is positive 1. What's I to the 5th?
Negative 1.
Close. I to the 5th I'm going to write as I to the 4th times I, which is 1 times I. So it's just I. It's positive square root negative 1.
So it just alternates.
More alternates means just 2 things it cycles through.
Fine. Alternates 3 times.
It repeats how many times? 3 or 4? It doesn't repeat 4 times? You go from I to negative 1 to negative I to positive 1 back to I. And then, yeah, what'll I to the 6th be?
Negative 1.
Negative 1, because it'll be I to the 4th times I squared, which is 1 times negative 1, which is negative 1. So it cycles 1, 2, 3. It cycles through I, negative 1, negative I, positive 1, I, and then it starts repeating. So with that in mind, so part of the homework could be, what is I to the 57th power? And you'd have to figure out where in the cycle that fits. So that's multiplying I times itself repeatedly.
It would be negative root negative 1. Then I to the 3rd. Or no. Yeah.
I think you're right. I'd have to check. We'll check that tomorrow.
Look, because it will be whatever I to the 7th is.
Wait, I to the 57th? Wait a minute. Dean's got something here. I want to figure this out. I to the 57th. Dean, you think it'd be where?
I think it'd be the same as I to the 7th or I to the 3rd.
Negative I?
Yeah.
Okay, let's see. It's...
Instead of 80.
Yeah. Okay.
Like,
It's I to the 56th times I, right?
yeah.
Okay, guys, we're figuring out I to the 57th. Dean says it's I to the 56th times I. I to the 56th is I to the 28th squared, right?
Yeah.
Okay, what's I to the 28th going to be? What is I to the even exponents? Always is...
It's always going to have like a 1 with it.
It's always a negative 1 or a
So
positive
it's going to
1?
be positive 1.
Well, which one's it going to... I think
Oh, wait,
it's...
Isabel, can you move for a second?
Yeah.
It's me negative. It's me square root of negative 1.
I think it's going to be positive.
I'm going to keep going with this. It's I to the 14th
Oh,
squared
yeah, positive. It's me 1. It's me
twice,
1.
right?
It's me 1.
Is that right?
I might expect my
Okay, guys, am I allowed to do this? Take a look at what I'm doing with the exponents. Am I allowed to do this?
Yes.
Yeah, I don't know.
Okay, I'm allowed to, but...
Yes, because if you multiplied it out, you multiply 14 times 2 and then...
Yeah. So it's I to the 7th squared... It does look really weird, kind of psychedelic. I to the 7th squared 3 times, right? What's I to the 7th going to be?
Square negative 1.
I to the 7th is going to be I to the 6th times I, which is going to be
Negative
negative I. Okay, so this is going to be negative I squared, squared, squared times I. Okay, so what is negative I squared?
Negative I.
Negative 1.
Negative 1. Well, close.
No,
I
wouldn't it
squared
be
is negative. I
positive
squared
one?
is negative 1.
Wouldn't it be
And
positive
then the negative
1?
of that is positive 1.
So 1 squared is 1 squared is 1 squared. So all that is just 1 times I.
Yeah, so that's just going to be I. I to the 57th is I.
And
Let's show us over.
That took some thought and a lot of parentheses on my part.
I was close.
Yes, you got one of the 4 possible choices.
The negative.
The
No,
negative,
I
yeah.
narrowed it down to 2.
You did narrow it down to 2. You're right, you did. You did. Okay. This can be fun.
I'm not going to write all that out. It's too much work.
Okay, everyone have this part down?
Not quite.
Okay, all right. Now, we're going to go on to when you multiply actual complex numbers, you only have to deal with one of these exponents. If you're multiplying 3 plus 5i times 2 minus 6i, what do you think you do? Distribute. What's a shortcut for distributing 2 binomials? What do we call that? Foiling. Yeah, we're going to FOIL this. What's 3 times 2? That's your inner. That's your first. Excuse me. Outer. What do you think 3 times negative 6i is?
Negative 18.
Negative 18i. Works just like that. What is inner? 5i times 2.
10i.
Plus 10i. And last, that is not last.
Minus 30i.
Thank you. Minus 30, actually I squared.
Yeah.
We have an I times an I. And what did we say I squared was?
Negative 1.
Negative 1. I squared is negative 1. So here's what happens. I combine these two like terms, and I get minus 8i. Double check me, please.
Mm-hmm.
Okay? And then this is minus 30 times negative
So
1.
it'd be plus 30.
Yeah. So what's going to happen every time you FOIL 2 of these?
You're gonna end up with binomial.
But wait, can't you?
Foiling?
It's not done.
Right before this.
Hold on a second.
And you have a number and an I. What's that?
Complex number?
Yes, it would be a complex number.
You're always going to get a complex number, and then what was...
It's not done. It's going to be 36 minus 8i.
It's not done. Very good. 36 minus 8i. We'll always wind up with a complex number when we multiply two complex numbers. Almost always. There's one exception. I'll do that in a sec. And you'll always wind up... The last term will always be a number times I squared, so you'll always wind up flipping the sign on the last term, because it'll always get multiplied by negative 1. Okay, there's one exception to what Saul just said about always winding up with a complex number. Okay, and that one exception is if you follow this pattern. What do you get when you multiply a times b times a minus b times a plus b? What do you always get? You guys were doing this backwards just on the last test.
Wouldn't it be like a squared
A squared minus
plus
B
no
squared.
There's no c's.
no there'd be a squared plus ab minus ab minus b squared.
Correct. And what two of those terms will always drop out, and this is the difference of squares factoring pattern. If I give you this and ask you to go back to this, it's a difference of squares factoring pattern. What happens, what Amy just worked all the way through, is you get a squared, outer gives you plus ab, inner gives you minus ab, and last gives you minus b squared, so two terms always drop out. The same thing works with complex numbers. You can FOIL it every time, but if you get this pattern down, it'll go a little faster. So if I give you 2 minus 3i times 2 plus 3i, either by FOILing or by using that pattern, what will that give me for my answer?
4 minus 9i squared.
4 minus 9i squared. And what's I squared?
Negative 1, so 4 plus 9, which is
Yep,
13.
4 minus 9 times negative 1, which is 13. So I just multiplied two complex numbers together and only got a real one. That only happens if you follow this pattern. Okay, where you have the same real term and the same unreal term, but there's subtraction between them in one case and addition between them in the other. Okay, and those two, you multiply two imaginary things and you get something real. It's like breeding 2 unicorns and getting a donkey. If that made sense to anyone but me in here, I'll be pleasantly surprised.
You made some of them.
You're on your own.
That's okay, good. All right, now, in this case, these get a special name. Terms that have this relationship to each other. A is the same, B is the same.
Like terms.
No, those are the real ones or like terms, the unreal ones. These get a funnier name than that.